There are a lot of series on Git already out on YouTube, but I simply feel like they approach Git from the completely wrong side and make it sound just so bureaucratic and boggy. Let's try another way. Usually, whenever you're working on a project, you'll have a folder with a few files inside. Say you have a file explorer letting you open, copy, move, and delete these files, and a text editor that lets you read and write text or code. If you've typed some text, accidentally deleted too much, and saved it to a file, oh no! What do? You press Ctrl-Z, the change is reverted, you save it again, and the file is as good as new. If you wanted to return to that change, you'd usually press Ctrl-Y, or, if you wanted to go back even further, you'd press Ctrl-Z even more times. If you accidentally delete a file in the Explorer, you can also just press Ctrl-Z to return to it without going into the trash bin, and to remove it again, Ctrl-Y will also work most of the time. But trying to do Ctrl-Z again after that may not even work. In fact, pressing it more than once may not work either. But why? It all has to do with how these tools remember your changes. Both the Explorer and the Editor have a temporary memory of what you just did. The Explorer will normally store the last instruction it followed, like move file at address A to address B, and when you decide to unwind, it just reverses that action. Here, by moving the file at address B back to address A, and clears its memory, sighing in relief that you'll probably not need to rewind that action. It can't store much more because files vary in size and you may be moving around gigabytes or even terabytes of files. But text is very cheap to store and operate on, so your editor has the luxury of storing a very long list of individual changes that you made to a file while it was opened. Here you added a sentence, here you rewrote it, here you moved a paragraph across the file. When you unwind, it reverses the change by just replacing the text that was added with the one that was removed, or vice versa, and will only forget changes once they reach a limit or you made a new change after unwinding the previous one. But rewinds are common enough in text to allow you to do lots of them. But for both of these, when you close the windows, they forget about what happened, and if you reopen them, you get a blank new slate of history in each. This is non-persistent or temporary memory. It's like arcade games that will remember how many lives you've got and how many enemies are left while you're playing, but once it's game over, all that progress is gone. One example of a program that uses persistent or permanent memory to store your actions would be a web browser. Unless you are browsing in incognito mode, your page visits will be recorded in your history, with timestamps and URLs, regardless of when you closed or reopened its window. But your web browser also uses non-persistent memory to remember the last few visits you made on a certain tab, and you can use the back and forward arrow buttons to quickly unwind and rewind to whatever places on a website or even multiple websites you went to. And all of that is also recorded in your browser's history. But once you close that tab's temporary memory is gone. And while all these programs keep track of user actions and allow you to unwind and rewind in some way, another thing they have in common is that they only care about what you're doing inside of themselves, but not in other programs. A file explorer can't unwind the change made to a specific file in the text editor. If we add another tool to the squad, like an image editor, then we have a program that can make changes that the text editor can't understand. Oh no again! What do? One solution is to emulate persistent memory by storing a copy of the last good version of your version as a backup, returning to it manually if something goes wrong at home. This is also the simplest way to share updates of your work with people. You just start numbering these copies like 1.0, 1.1, 2.0 and so on, and if you know you made a mistake in one of them, you can go in and revert it and share it again. And every time you do that, you double, and then triple, and then quadruple the storage your project takes up on your device. And deleting older versions means you have less project history to work with, and it's not good. You know, if only there would be a way to store my project's history with versions and changes easily and efficiently, and to have it accessible to other people, and introducing Git itself, the modern version control system that keeps track of changes in files in a particular folder and helps you and other programs that support it keep your project intact, no matter its size. Like all good things in this world, it was created by Linus freaking Torvalds, eventually joined by a massive worldwide community of developers and just plain enthusiasts, and is freely available on all operating systems. Git doesn't watch what buttons you press. It doesn't record, you move the file, or you type the line. Git only cares about one thing, how the files in this folder look right now compared to how they looked before. When you use Git, you're basically teaching a folder how to remember itself over time. Instead of storing entire copies of a project like backups do, Git stores snapshots of changes. When you say, "This version is important," Git freezes the current state of all tracked files and gives that moment a name. Git's persistent memory can be first thought of as a straight line with dots on it. Those dots are called commits. Each commit is a permanent memory of what your project was at that time in its history. You can close the editor, shut down your computer, come back in a year, and Git will still remember if you told it to. And here's what's so smart about it. Say you add a paragraph or two to a text file in your folder, and you tell Git to remember that. You may close it, come back in a few hours, add a sentence more, close it again, then come back in a day, and so on and so forth. You make 5 commits, or dots on your timeline this way, and Git will remember 5 snapshots of your project. But it won't recopy the files you didn't touch, and for the ones you did, it will only store the actual changes made, kind of like how text editor did it, but much better using its own compression, without having to go and Ctrl-Z one by one just to jump from your 5th commit to your 1st. This is what also makes Git good with not just text files but also images and other small binaries. Emphasis on small, as you probably don't want to stuff a 100 megabyte tutorial MP4 into a commit. Going back to the remember that part, it's pretty neat too. All the changes you make to the project before asking it to remember it are also tracked by Git, and you can see how your files differ from the ones Git remembers at the last commit of your timeline. This system is so flexible that you can even tell Git to only pick a few select changes in a few select files to be remembered. That's called staging. And to only commit those, and leave the rest of the changes out of the timeline for you to refine and maybe commit later, without having to worry about publishing an unfinished feature. At this point, Git is already giving you a reliable, permanent memory for your project, even if you're working alone. And did I mention that you can collaborate with people easily too by having them share their own commits? And also how easy Git makes it to share your work on the internet?